Okay, so let's get started. This is week 5 of IT 140, and this week's topic is the Python functions. So function is a very important programming construct for any programming languages, and it represents a step up in your programming career, where you can, use function to decompose your features in software and write maintainable modular code, right? So function is there to help you organize the way you program. And hopefully by the end of the lecture, you'll appreciate why function is important and how to use them. Okay, let's get started. Previously we only talk about some piece by piece the language feature from Python, how to do a sequential statement, how to assign variables, how to do loops, and how to do branches, and et cetera, right? So this week we switch gears and talk about how to put code into a maintainable and repeatable, reusable state. Okay, so how to hide the details, implementation details from the interface, or we call the API, application programming interface, right? So how to make a library so that other programmer can use your code and to, on top of that, build application on top of your libraries. So things are starting with functions, okay? So I think I mentioned this. So what is a good programming style, you may ask, right? Is programmers paid by the number of lines of code they wrote? Obviously not, right? If you are paid by the number of lines that you wrote, then this guy must be very rich, right? So Bill Gates has a famous quote: measuring programming progress by line of code is like measuring aircraft building progress by weight. So that's basically tells you program you want to write a clear code. And what is a clean code, right? So take functions. So what, for example, if you have a projector, it's like Project Black Box for you. And do you need to understand internal working of projector before you use them? Obviously not, right? You just need to know the interface that you can interact with projector. For example, you have to power on, how to turn it on, and how to play videos and such, okay? Adjust the distance and etc. Right? So for any programming construct is also the same thing. You want to know what's your input, what's your output, and as long as you define those clearly, you have a black box or function that can be used somewhere else. People can just take your function spec and know what's the input, what's the expected output, and that's fine, right? You can modify how this function looks like as we see fit, but then you have to, you may want to just fix the interface, right? So this is the idea of decomposition is like you divide your big problem, a big project, into several smaller pieces, right? So from this week on, you will work on your project where it's a text-based game, right? So obviously it's a bigger project, code features that what you wrote in Zybooks, right? So it's much a bigger scope. So it's, if you write everything into a one function, then like a main function, that's not maintainable, or maybe it's spaghetti code. But if you can divide those features into different components, like maybe one function to do, how to retrieve items in the room, and one is how to navigate the room, one is getting user input, one is you know, detect the game and logic, etc. And then you can just put all these functions together to finish your project. So function is super important for those kind of things. This is the Olympic Games in Winter Olympics in Canada, and they use multiple projected project the bigger picture. So you need a coordination from a lot of different devices to achieve end goal, and that's what the function does. Okay, so much for the analogy. Okay, so how to write a function? How to write a function in Python? Let's give you a example. Let's start on here. So, or maybe I can just try it here. All right. Okay. So first of all, to define a function, you need to write a keyword def, means define, right? And then a function name. Function name needs to be very descriptive. So people look at the function name, they should be able to guess what the function does, right? Let me see if I can do a job here. Area of a circle, right? So you guessed it. That's the area of circle, and you can have a parameter. Obviously, you need a radius, right, as your parameter to calculate the area of the circle. Okay, and now, so here is a function, right? So you have a keyword definition, the function name, and in the parentheses, the parameters that you're gonna use for your function. It can be empty, so your function may need nothing, no input, right? And then you can give output or not. But the path is just a temporary placeholder so that the function is valid. When you run it, it won't issue a error for you, and you can actually finish that later. Okay, so that's a basic constructor function. You have a keyword, a function name, and parameter. Now, it's recommended that you write a docstring. Remember docstring, which is the 3 codes, triple codes, right? And in that, you can define your function spec, right? The function spec is like contract between developer and user. So you want to promise what your input is, like input is the radius of a circle, right? Should be non-negative real numbers. Okay, so that's your expectation, and you'll get output area of a circle. Okay, so that's pretty much that's called docstring, right? So it's documentation on your function. Now, of course, this part of the code is not going to be parsed or executed by the computer interpreter. It's just for human to consume. Now you have, once you've done that, so you're going to write how to implement the function, right? So you're going to do some data processing of the input, right? There's a lot of error checking on this, input. Sometimes you want to make sure that radius is greater than 0, right? You can't trust the people who passing that number to you. So you have radius is less than 0. What do you do? Maybe return none, right? None means not a number, okay? So now it's greater or equal to 0. So you can use a variable called area is equal to mass.pi. Okay, mass.pi is a constant inside a module called mass. So I'm going to import that, right? Import mass. mass.pi times the radius square, right? Square is like this, 2, and use a parenthesis. Okay. What's going on here? Oh yeah. So now you can return area. So return is another keywords that is new here. So return basically say I want to, so you give me some input, I want to return the output to you. So when people who call my function will get the return value, right? So up to this stage, you have finished define a function and implement the function, okay? So how to use the function? Well, it's just like use any other function in the built-in Python libraries. You can just call that function, right? So just like your print function is a function that somebody else, like calling my own functions, right? So I'm gonna call area, area of circle with radius maybe 5, okay? Now it returns the number area, so we need to grab it from maybe a variable, right? So now you can print area of a circle with radius is and format radius of 5 is area, okay? All right, so let's run it. Area of circle with radius 5 is 78.53. All right, so you may want to put a unit there, like centimeter, meter, but that's not too critical. So basically, this is a complete function implementation, definition, and how to use the function. So basically, in terms of functions, there's 2 steps, right? One is define the function. You have a function name and a list of parameters, and then you can return stuff, right? So here you go. And this is another example of function. And also, this is a very typical name. So you can guess the function does take a positive integer and returns true if I is even, otherwise it's false, okay? And it will just, this is function body, I return, I modular 2 equal to 0, that's an even number. If it's not, then it's an odd number, right? So, and then after that, you can call that with a parameter 3. It was supposed to give you a true or false, okay? So yeah, these are the components or functions. At the minimum, you need a def keyword and a function name. Now, the parameter can be empty, but you cannot skip the parentheses, right? Even though we have no parameter, you still need a parenthesis. And also the colon is important. You cannot ignore the colon, just like if statement and while statement. And then you need the indentation in the function body to show Python, this is my indentation. This is my function body, right? After you're done, when you call it, you go back to the original indentation so that Python knows now this is returning to outside the function and I'm gonna call it, okay? So parentheses, colon, and indentation are important. Okay, so let's talk about the scope of the variables that you pass into a function, okay? So notice that this variable x, now we call, so there's a name for it, right? It's f of x, we call this is a parameter. And when you call the function, you pass in what? You pass in a argument, right? So the argument can be a number, like 3 or another variable that holds that number, okay? When you pass in this x is a variable holds a number, it will be bound to this this parameter and be used inside the function body. When that happens, okay, it depends on what kind of variable it is. If a simple variable like a scalar variable, like integer or float, it's gonna be just a copy of that variable, right? So internally, this x is only limited to the scope of this function. Outside the scope, when you return x, this internal x does not exist anymore, okay? And the return value will be passed to this caller and be assigned to this variable, okay? So to illustrate that better, I'm gonna use Python tutors. That's an awesome tool when you are trying to visualize what's going on with the function, right? So let's try it. Define f of x, right? X inside is x plus 1, and print x, and then return x, right? And outside it, I have x equal to 5, and print f of x. Sounds good? Let's see, what did I miss? Okay, yeah. And yeah, okay. I maybe say inside function f, all right, comma x. All right, so let me assign this to a variable z, okay, equal to fx. All right, so now I'm gonna just print z. Okay, visualize. So first of all, you can see here, I define the function. It will be saved into a global frame with a pointer f pointing to that object function, right? So when you assign x equal to 5, the x is creating global frame. You have variable x called a variable called x, and its value is 5. Now, when you call the function, you notice that the arrow goes inside the function now, right? It creates a new frame called f frame. It's a frame for the function, and then it itself has a variable called x. Okay, so that x is local to that function. All right, so now an x is plus 1, x becomes 6, and it's inside the function f6. When you return x, this return value will be passed back to the caller. But notice what happened is that f frames get destroyed. That means all the values that's temporarily inside the function is getting destroyed. The only number that's getting out, messaging is that return value 6. So z is assigned to the 6 as a result of the function calculation. And the original x on the global frame is still 5. You see that? So don't confuse this x with that x. X will be different. It's a global, it's outside the function space and the inside the function space. So at the end, it will be printed as 6. Okay, so I want to pay attention to the scope of the variable inside the function. It's going to be a new scope, so it's different. That's key. All right, so we did that. So sometimes you see the function has no return statement. If that happens, it actually still returns, but the return value is none or no value. Okay, so there's some function that don't need a return value. It only does something. So that's totally fine. Return versus print. So you can see print statement everywhere and has multiple print statement inside the function, outside the function. So print statement can be used anywhere. However, in the return statement, there's could be only one, how to say, So only one return executed inside the function. You may see multiple return statements in the function in different branches, but at the end of the day, there's only one return statement being executed inside the function for each run. Okay, so any statement that's after this, the return statement will not be run. However, it's perfectly fine to have a multiple print statement and they will all be run. Okay, so and the return statement is only meaningful inside the function body, and it's not meaningful just as is. Okay. And also, there is some advanced ideas. Function, just like a variable, right? It can be passed as arguments as well. So function, is an object, right? When you, call a function, you're executing that function. But if you just pass a function name, that function name is basically an instance of that function, and it serves as object. And basically, if you get a function name, you can use a parenthesis to call it and to get the result. Okay, I will say it again. The function name serves as an argument. It's object. And when you get that, for example, this function C, it expects an argument Z, a parameter Z, and the Z is here passed as a function name as argument. And that function name, when you grab it, you can actually use parentheses to call that function. So the parenthesis is like actor, right? It's act on that function to execute that function. Okay, so I guess it's a little bit advanced concept. I'm not gonna do too much things about that. But as you can see, when you run this function, it's normal. It's just to run the function and get the value, right? In this case, there's none because this function A didn't return anything. It's none. And function B does return anything. It returned the Y as is. So you pass the 2, you get the 2. So 5 plus 2. Function B2. Yeah. And then here, yeah, you get a 7 by running this, right? And the third function is very interesting. So you first pass a function A, all right? Function A, and in the function C, you call that. When it's executed this, it's calling the function A. It's inside the function A, and its return is none, right? Because A function returns none, and it will be passed back to C and also returns none. Okay, so you can see Z is a synonym to function A. Okay, so much for function. There is another concept of global variable versus local variable. So, but again, global variable is usually not a good function design. So be aware, don't use that often. But the problem is, the question is, if there is some variable that inside the function is not defined here, it will see outside the function and grab whatever the function first defining. For example, in the middle column, you have a function G, and it print X, but there's no X anywhere here defined, right? So it go out and see, oh, X is 5. So it will print 5 and then print 6, right? That's perfectly fine. As long as they're just reading the function, okay? The X here, in this case, is inside the G, but also is picked up from the scope that's called the function that's outside the function G. Okay, here, X equal to 1, X plus equal to 1, X is 2, print X is 2. X is 5 has no effect on it, right? Because it will first look for locally, and only if there's no scope X defined here locally, they will look for the parent and or the outer scope. And here, this is illegal, right? So you're modifying the X inside the function. That's no, okay? You can't do that. If you do that, Python will throw the error. local variable X reference before assignment, right? So if you want to do that, you have to first either define it locally, or you can declare this X as a global, and then you can modify it. When you modify this, the X will be changed outside. So it's unexpected, and so don't do that. All right, don't do that. It's not a good practice. Now, there's some caveat of function parameter. So let's say instead of giving a integer number or floating number as a scalar, right, function, what if I pass it as a list? So let's define another function. Okay, let's define another function. For example, let's define list ops. Okay, so I'm expecting a list, a number list. Okay, and I am trying to, so number needs to be a list, right? And I'm trying to change that list. Okay, for example, I'm gonna do number is equal to, how to modify that number. Let's say X for X in num, right? If X modular 2 equal to 0. What does that mean? So if X is an even number, I will keep the X, otherwise I will skip it. So number will be a list of even numbers. Okay, and that's it. I didn't return anything, as you can see. So let's call it list of ops and give them, okay, let me just assign a number outside. Right, I'm gonna give them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so list of 10 digits, and I'm gonna call this num, and then print num. Okay, and I'm gonna print num here, although I don't need to print. It's okay. Actually, I can just simplify it. Is range, not range, X for X in range 100. Okay, 100 numbers. All right, let's just try it. So here. Okay, I'm gonna run it. So you can see original number. Wait, yeah, there's nothing changed. List of ops print none. What is going on here? Yeah, so okay, let's try this, right? So I'm gonna modify the number of 2 is equal to 100. Okay, so I don't need that too much. All right, so let me run again. All right, so here you can see that I am modifying the number. The second element, the third element is 100, and after the function, this one is getting changed. So what's going on here, right? So let me put into a Python tutor and at this code, and let's take a look. Okay, so what's going on here? Yeah, realize. So first of all, you can see that in the global frame, a list of operations function is defined, and my number is list is generated, right? 0 to 9. Okay, so now I'm in the function. You can see the number. Okay, here is pointing to the same list, right? And that's exactly the reason that when you modify number 2 is 100, you're actually going to the same list and modify the 100. And once you're done, you return none, but the none number here, although that pointer to this is deleted because the function is deleted, but this list still exists because there's still a pointer points to it, right? So when you print out the new list of 100 is you know, changed. I'm just curious, number equal to what happened. So like what happened if x in num if x modular 2. Actually, I'm gonna do this range function, right? You can slice the range of the list. So let me do every 2, okay? So let's see what's going on here. And I'm gonna do, all right. So number, I'm gonna list numbers. All right, here you go. So basically, whenever I have assignment going on here, right, it will break that, you know, link and just make this local variable because this number is my local variable and pointing to a new list, right? So the original number and this number is diverged. Whenever I have this equal sign, this local variable number is created and pointing to a local copy of that original number. Okay, so that's why when I return, the number didn't change. Okay, but if I did this number operation, I didn't do assignment, right? Then number will keep that. Let's say number 2 equal to 100, right? So this one is not break. So number is still pointing to the outside. Okay. Same thing for string. All right. So if I have a string 1 equal to like this is awesome, right? And string 1 and I'm gonna do just not list operation anymore, right? But this number refers to that string 1, right? So I can use a different name to reference to this, okay? And then now string is immutable, right? String, because string is immutable, you cannot do this. This will like change this character to C. That's a no-no. So in string, when you do number equal to number maybe 2, like that, it will print. There's no number, string 1. It will copy it. All right, so let's try string 1 and see here, number is being copied, right? So the number will be a different one, but it's copied, so it will not affect the original string. So original string is still the same. Okay, so that, you know, makes the scope very interesting. All right. Yeah. So you can also define a function inside the function. So this inside the function only visible inside the outer function, right? So that will make the scope more complicated, but if you look carefully, you should be able to figure it out like this. Okay, I have defined a function inside a function. So let's just run it. So first of all, you have a global frame of G, and you call this function G, and then you define another new function H inside this global frame. And then this X is inside the G, right? It's local, so it's different than the outer X. And then you call this h function, which is defined here. And inside the h function, you can see this another x. Now this x is nowhere referred inside. So this x actually is outside the h, right? But when, oh, sorry, this x actually is local to h. Sorry, so because you use the assignment, so the x is internal to ABC. So it's not the parent x, which was 4, and it's not the global frame 3. So there's 3 x's here. Each x are only local to that particular stack or frame, right, of the function. So this internal x ABC is limited to this function h. And that x4 is limited to the function g. And finally, this 3 is limited to the global frame. So once the function is done, that x is destroyed, okay? And then you are here, and once that's done, okay, the return value is 4, but that x is destroyed as well. So now finally, you get x is equal to 3 and z equal to 4, which was the x inside the g of x, okay? So yeah, function scope is really, really important. So make sure you understand this. All right. I guess that's the function. So final thing about the function is that you can, so normally this parameter are positional. That means you assign first name, last name, reverse sequentially, right? Whenever you give them calling a function, you expected that you give the first name first, last name second, right? However, sometimes you will give things like that. So if you say last name equals Smith, reverse equals false. So this is called the key value pair, right? We call it the keyword argument. So if that's the case, if you specify the key of that parameter, then there's no ambiguity. Python will assign the value to that particular variable. So in that case, that also means that this variable can be placed anywhere in the calling list, right? The parameter list. You don't need to be positional. However, you have a mixture of positional and keyword argument. The positional argument should be the first. That's easy to understand, right? Because otherwise, how can Python understand where you put the positional argument? What's the position, right? So that's the rule of thumb. Usually you will see either all positional or all keyword. Really, you mix them together. It's not a good practice, all right? So that's the positional function. Parameters. So I guess that's pretty much it for the function. For this week's lab, okay, I think they're pretty simple. Let's take a look at the swapping variables, okay? That's extremely simple, right? Let's take a look at it. So you define a function called swap, right? You have two variables, A and B, okay? So what you do to return, you want to return something, right? Return a tuple such that when you call it, right? So let's say A equal to 4, B equal to 5, right? You want to swap A comma B, right? And you want to assign to A and B. So this is how you assign function. So a function in Python can also return objects, right? This is like a tuple. So by doing that assignment, you literally return two numbers, A and B is swap A and B, and then let's print A comma B, right? Let's just print A comma B, all right? So it depends on your function. I want to see 4 and 5 in the first, and once swapped, I want to see 5 and 4. So how to implement that function, right? Well, you just return B comma A. That's it, right? Run it. So 4 and 5, 5 and 4, right? So that's there for how to swap two values. It's really simple. Now in textbook, they they have some like temporary variable, temp equal to A and A equal to B and B equal to temp. that works too. Okay, but that's so much unnecessary in Python because Python already have something for you, right? Return A, comma B. Let's see if that still give you a good, yeah, it's still good, give you a good result. Okay, so yeah, that's the swapping variables. Very simple. How about next lab, exact change function? That's actually similar to what we already done previously, right? Use an integer division for the remainder of each coins, and you start with the strategy is starting with the biggest face value coins, right? That will give you the least amount of number of coins, right? Because they always start with the big face value, and then you go smaller until you're exhausted, and you go down to pennies, right? So yeah, just to write that same function, just you need to define a function, right? So this name equal to main thing is basically so basically what happens if you run Python as yes, it will be executed, right? So the name is a main function. But if you run Python as a module, you import this Python file as a module, this part will never be run, okay? This is just to ensure that when you import other people's code in a library, you won't be accidentally executing that code. Because normally when you import the Python as a module, your intention is to use the function that defined in that module and you call that function later. You don't want people put this line here to test the module usually, right? So you can test whatever you want in the module, but when other people import your function, it will not be accidentally called, right? You want to, you don't want a surprise of are you calling other people's function by importing this number. So for example, let me give you an example, okay? So let's create a module just called the module1.py, right? For lack of better names. So inside it, let's say define a function called fun, right? So basically it will just do that. No, I don't need a parameter. I just print I am a module, have fun, okay? And then if name is equal to main, okay? What I do is I'm gonna test it. All right, I'm gonna say testing the module here. Okay, so if I run this function, and I'm gonna just call fun. All right. So if I run this function, oh, I'm sorry. I need to go to a shell and run it. So I'm gonna say Python module1.py. You can see both statements I execute, right? Testing the module here, I'm a module, have fun. Okay, so we have done this. So when you run this as a full module, this part is being run, all right? So now in our main function, let's import not only mass, but import module1, okay? Import module1. And here I'm gonna print, okay, I'm not gonna print here, I don't, all right. Comment this, comment this. And I'm gonna just print module1.fun, okay? So that means the function is inside module1, right? Let's run it. You can see I'm a module have fun, right? So basically, Oh, actually, I don't need to print that. I just call it. Otherwise, this none, by the way, is the return value of the function because we didn't return anything. So that's none. Okay, let me run again. So you can see it's just running. I'm a module, have fun. Where is that? This print message will never be run because Python knows when you import it, it's not, the name is not main as a module, so it will not be executed. So that's it, right? So that's how this name equal to main means. All right, so I think that's pretty much for this chapter. I feel like maybe I should talk a little about the recursion functions, but sounds like maybe I shall just briefly mention it. Another, interesting use of the function is to call itself, right? What is recursion? Recursion is a process repeating itself in a similar way. So sometimes you define a function, you can call itself, but with the condition that every time you call the function, you will change the parameter a little bit until at the base case, your function will stop, execute, or return something. Otherwise, it will keep calling itself, and you have what? You have a stack overflow, right? And functions are saved on the stack, and stack has certain limited size. If you keep calling it, it will eventually hit the end. So if you understand recursion, there's a lot of whole algorithm that depends on that concept, okay? So what is recursion? I give you an example. If you multiply a and b, that's a simple function, a times b, right? It's similar to a plus a b times, okay? That's good, right? So you can write this function as addition. So basically, you just add a multiple times. Every time you add a, you subtract b by 1 until b equal to 0. So you finish the multiplication. That makes sense? Now, if you write a recursion function, you can think about it this way, right? You can think about a bigger problem in terms of a smaller problem. So for example, here, a times b, you can think about is a plus a b times, or it's a plus this one b minus times, and it's basically a plus a times b minus 1. So for this concept, you can define a function as a recursion function, recursive manner. So it's basically the a plus the multiplication of a times b minus 1, right? A times b is equal to a plus a times b minus 1. So this a times b minus 1 is also a function that you can call on the self. This time the b become b minus 1. And then it's also equal to a times b, a plus a plus multiply a with b minus 2 and b minus 3, and so on and so forth. Until the b is equal to 1, we're going to return a, because when a b equal to 1 is a times 1 is a, right? So you just return. You can even go b equal to 0. Then this time, what you return? You return 0, right? Because a times 0 is 0. So this is called recursion. All right. So let's try it. Recursion. Right. So define mod a comma b. Basically, you need a base case. If b equal to 0, right? Return 0 because a times b is 0. And else you just return what? A plus mod a times b minus 1, right? Every time you subtract 1. All right. So that's it. And then just run it. All right. I'm gonna call it print mod 3 times 5, right? 3 times 5. Okay, run it. It's 15, right? So that's fine. So 3 times 5 is 15. Now, how does that work in Python tutors? Because I want to see the frame, right? So it's using Python tutor. Again, this is a very good tool. You should play with it. Okay, so let's run it. So first of all, I have, oh, wait a second. I need to also call it, right? So I just, let's say print mod of 3 times 5. Okay, so now visualize it. Run it. Missing requirement B. Oh, I see. It's comma 5. You're calling that function, right? You need to supply 2 variables. Okay, that's fine. So A is 3, B is 5 to start, right? And then B is not 0. It's not base case yet. So you return A plus, now you create another function. So it's calling itself, but this time B is 4, right? And then it's still not a base case. It's calling itself. You see B is 3, right? And it's not base case, so it's calling itself. B is 2, and so on, and 1. And then B is 0. Now this time it's a base case, so it will return 0, right? So when this returns 0, and up to, let's go previous one, right? It's 0, return value 0, A is 3, right? So here it will call back. So it's 0. Remember, this is 0, right? But this A is whatever the A on top there. So it's 3 plus 0. So the return value is 3. Got it? A is 3, right? Plus whatever the return value is 0. And when you go there, it's 3. And then remember, this A is 3 and return is 3. So next time you return is 6 because 3 plus 3 is 6. And remember, A is 3 and plus 6 is 9. And then plus 6 is 12. And plus 6 is 15. And at the end, you print 15. So that's recursion, right? If you understand this picture, then you understand recursion. I guess that's limited time. I'm going to talk about maybe another interesting thing about Fibonacci number. So basically, a Fibonacci number is based on like rabbits, right? So you have a newborn pair of rabbits, 1 female and 1 male, and the rabbits made at the age of 1 month. Rabbits have 1 month gestation period, and so it never die. Okay, the grandparents never die. The female always produces 1 new pair every month. So at the end of like n months, how many pair of rabbit it is? So that's a problem, right? That's a problem that you need to solve. How many female rabbits are there at the end of 1 year? So basically, this problem can be formulated as a recursive condition. So the base case is initially you have 0 months, you have 1 female, 1 male, and month 1, because they haven't have a baby yet, so it's still 1 female. So 0 and 1 is 1. Now for the next month, you will have a pair of rabbits. So the rabbit female number is n-1 plus n-2. Okay, that's a recursive condition or state transition function. All right. So every time you look for this month's number, it's basically the previous month plus the previous month's number. So that's Fibonacci number. So how to write this recursively? Well, this already gave you a recursive condition, right? So this is the same function, but with a smaller number. In this case, there's 2 base cases. So let's try it. Actually, let's try it in Python tutors. Let's define Fibonacci number of n, right? So base case, if n equal to 0, return 1, right? If n equal to 1, also return 1. You can actually combine this. For n equal to 1, return 1. Else, just call fib of n minus 1 plus fib of n minus 2, right? So just return that. Basically, it's fib of n minus 1 plus n minus 2. And if I want to create a fib of 3, right? So let's visualize it. Initially, fib of 0 and 1 is defined base case, and then it will recursively call this until you hit equal to 1, right? And you have 2, you have 3. I think there's something wrong here. Let's look at that. I think that's correct. So hold on. Did it get the number? Yeah, Fibonacci 3 is 3, right? Because it's 1 plus that, right? So let's just print out, make this on paper, right? So Fibonacci number of, let's see. Initially it's 1 and 1, and then it's 2, right? And it's 3. So yeah, Fibonacci number of 0, 1, 2, 3. 3 is 3, and then next is 5, because 5 is 3 plus 2, and 5 plus 3 is 8. 8 plus 13, 13 plus 8, 91, right? And then you add 34 and 55 and 89, right? And then 144. So that's the Fibonacci sequence. And if you run this Python code with, let's say, Fibonacci number of 8, right? And I see there's a lot of frame that's being called, right? So you can see it's calling this a lot. And then there's overlapping numbers, as you can see. So it's actually calling a lot of steps before it actually returns a useful number. It's very slow, you can see. It's really slow because it's repeatedly calling that number that's already computed, right? You can see this is really slow. There is a 270 steps that I'm trying to go through. 270 steps, come on. I'm gonna jump to the next step, right? So the answer is 34, but that shouldn't be that, difficult, right? As you can see, I'm just adding this, sequentially 1 by 1 and get 34. So why this recursive function is so slow? Anyone knows? Well, I let you already observed, it's calculating numbers repeatedly again and again, right? So you want to somehow use to remember this numbers already calculated. If it's already calculated, you don't want to calculate again to save time. So let's say if I say memo is a I'm going to say a dictionary, right? Okay, so a dictionary, and then, and I'm going to just pre-populate something, right? So memo of 0, which is a Fibonacci number of 0, is 1, right? Memo of 1 is also equal to 1, right? So I'm populating this memo with the key 0 and 1. The key is the Fibonacci number, and the value is the value of Fibonacci number, all right? So if n equal to 0 and 1, return 1. I don't need that. Well, I can already say if, because I already have that, right? If memo of you calculate Fibonacci name, right? Exist, right? If it's not equal to 0, right? Because initially this key is 0, right? That's using get n. Then I'm going to return memo of that n, right? So basically, I already have 0 and 1. So if it's 0 and 1, otherwise just return. Well, don't return. I'm going to save that to the memo. Memo of n is equal to 51, and then return that. So you can see I'm adding this memorization here, memo of n, right, to save time, right? How? Well, let's visualize it. Okay, initially the memo is empty. I'll actually fill out with dictionary, right? And then wait, memo. Oh, I need to change this because I'm calling this new function. I'm going to put the memo in, right? And actually, I'm also put the memo in here and memo in here. So every time I call this, I will carry along this memo, right? So it's like my lookup table. So right now it's 0, 1, and then Fibonacci of 8. So I'm going there. You can see the only 10 steps now, right? If the memo of 0 is not, wait a second, key error. Oh, okay. So here, what happened is memo of get n. Let's say what happens here. Previous one. So it says that this key is not existed. Let's see. Print. Print memo dot get of n. So I think I need to get this a 0 because if the get there's no key, I will get a 0, right? So let's just visualize it again. Hold on. Close. Yeah, that works. So you can see here, it's basically keep calling this Fibonacci until it gets to the bottom, right? It gets to 1. And here, it gets to 1 already, right? And here, because it gets to 1, it print out 1. So it's already calculated. And when you return it, see, this is 0 and 1. And then when you return it from the bottom, it's just keep print out, right? So now it's starting to calculate, because you see all these numbers are gradually filled in from those memo. It will save the Fibonacci number that's already calculated, right? 21, 13, 8, 5, 3, 2, 1. So it's gradually filling out the dictionary with the key value pair. So these are basically our Fibonacci number list, right? At the end, we're gonna return the last one, which is Fibonacci number 8 is 34. So you can see by using this memorization method, we actually saved the step from 270, right, to 80 steps. So it's drastically improvement over the naive recursive method. That is actually called dynamic programming method. Well, if without fancy word, but this is basically is a method technique to save overlapping problems. You can save that middle steps, and so that you can save a lot of operations. Okay, that's a very good techniques, and hopefully you can understand more about recursion and some improvements on those. All right, and don't forget, if you have a dictionary, if you have no keys, you will get key error, and until that's why you don't need using brackets, because these brackets will work only if the key existed. If it doesn't exist, it will give you a key error. So use the get method. It will be safer, because if key doesn't exist, you get a default value. So you're guaranteed to not throw an error. Okay, so that's a nuance difference between get method and a square bracket for dictionary. All right, so that's all for today, and hopefully you guys have a good weekend.